Hello everyone, and I hope that you're doing well. Today we're doing a quick review of the BGCSE Physics Paper 1 from the year 2022. Please remember, before you start the examination, you should always write your school number, your candidate number, your surname, and also your initials. As a gentle reminder, please remember to read through the instructions carefully and ensure that you understand each instruction. If you should have any questions or queries, please clarify those with the examiner before the examination begins. Let us jump into question number 1. And question number 1 reads that the diagram shows a block with two horizontal forces acting on it. The resultant force acting on the block is 50 newtons to the right. What is the frictional force? And so if the force that's going towards the right as a resultant force is 50 newtons, and if this force here that is given is 20 newtons, then the frictional force must be 5. So what we're going to do, we're going to say 20 minus 15. All right, because the frictional force will be in the opposite direction as the applied force. And so our answer there will be B, which is 5 newtons. For question number 2, you see a rock weighs 15 newtons on the moon, where the gravitational field strength is 1.63 newtons per kg. What is the mass of the rock? And so to do this, what you're going to do, remember that weight is equal to mass times gravity. And so therefore, mass must equal to weight divided by gravity. And so therefore, if the weight is 50 newtons, you divide by 1.63, which will give you 9.2 kg. And therefore, C is the correct answer. All right, let's go to question number 3. For question number 3, it said, which law describes action-reaction pairs? And so the law of conservation of energy simply state that energy cannot be created or destroyed, but may change from one form to another. And so that is not the law. And Newton's first law actually states that an object will resist change. All right. And it is also called the law of inertia. And so the law actually states that if an object is at rest, it will stay at rest. But if it's moving, it will continue to move in a straight line with a uniform speed unless it is acted upon by an unbalanced force. And for Newton's second law, it states that the rate of change of momentum is equal to the force, all right, which actually states that acceleration is proportional to the force and inversely proportional to the mass. And so the law that deals with the action-reaction pair is Newton's third law, which states that to every action there is an equal but opposite reaction. And you can expound on that law to state that if body A acts on body B, then body B will act upon body A with an equal but opposite force. All right, so this is the law that they're talking about here, which is Newton's third law. So it's good to know all the laws that apply to physics or we use in physics at this level. For number 4, it said, where is the air pressure the least? And answer will be D, which is on top of a mountain based on the other options. And the reason for that is because air pressure or atmospheric pressure decrease with an increased altitude. All right, so the higher you go, then the air pressure will be less. For question number 5, it said, which of the following is a property of gases only? And this is a relatively easy question. There's no need to really explain much in this. And so the answer here is A, which is compressible. So gas is compressible. Definite shape and volume applies to solids. Particles can slide over each other. That's a liquid. And strong forces between the particles, that will be a solid. All right, so this is just the state of matter and in terms of their properties as well. So you just see the relative questions that you need to review for your exam. As a matter of fact, the question will touch on pretty much every aspect of the syllabus. All right, I will only explain the questions that I think need to be explained. For number 6, it says, which change of state shows removal of heat from the substance with which is change in state. So you're looking at here, removal of heat and also a change in state. And so boiling, there is added heat for sure, not removal of heat. So this could not be the answer. And a matter of fact, boiling is no change in state. All right. So as the liquid solid boils, there is no change in state. All right. So for condensation is correct because heat is removed all right, and you also are changing state from a gaseous to a liquid, so a gaseous state to a liquid state. Evaporation is liquid to gas, and you also add E to them. For melting, solid to liquid, and heat is applied as well. So the only one that removes heat is actually B. So that's also a giveaway right there. That's a relatively easy question. For question number 7, it said 3 identical springs are hung from a ceiling. Calculate the weight W that is attached to the third spring. And so I can break this down into steps so it can be easy to follow. And so the first thing I wanted to remember is that the force is equal to KE, where K is the constant, E is the extension, and F is the applied force. And so for step 1, what we do here is if this spring, which is 10 centimeter, that is the unstretched spring. So when you apply 20 newtons to this, the spring will extend to 18 centimeters. So what we did right here is to calculate the extension, which is E, and so the extension equals to 18 minus 10, which is the length when the 20 newtons apply, and also 10 is the unstretched spring when there's nothing applied to it. So therefore, the extension is really 8 centimeters, right? And since we understand that F is equal to KE, then we can find the constant, and the constant will be now 20 divided by 8, all right? And so, which is the force divided by the extension. All right, and so once we find the constant, we can go ahead now and determine the extension on this third spring. So the extension will, since it's 24 and the unstretched is 10, so we'll say 24 minus 10 equals to 14. There's another way you could actually do it. You actually could see how many more the third spring stretch compared to the second spring. All right, and then you actually could add it to the extension here, which is 8. So if you look at it carefully, right, moving from 18 to 24, that is actually 6. So if you add 6 to 8, you actually get 14 as well. So there are 2 ways you can actually work out the extension, right? Now for the third step, once you determine the extension, which is 14 centimeter in this case, we already have our constant, which is 2.5. So all we need to do is to find the weight W is to multiply the constant, which is K, by the extension, which is 14, equals to 35 newtons. All right, so the answer there is C. All right, so jump into the next question now real quick, which is question number 8. It says, which object accelerates least when the same resultant force is exerted on each object? And so if you remember the formula, force is equal to ma, mass times acceleration, right? So the larger the mass, it means the acceleration will be the highest. All right, and so compare all these objects. Notice that B is in kg and also D is in kg as well, and so therefore 100 grams compared to 500 grams. All right, and 75 grams and 100 grams. So look at it in terms of grams, right? And so if you go back to the question, it said which object accelerate the least. All right, and so bigger mass, larger mass, you have the least acceleration, because the larger the mass is, it's more difficult to move, if you think about it in that sense, right? So the heavier the object is, it resists motion much more. And so therefore the acceleration will be less. Again, you can use the relationship F is equal to ma, all right? And so therefore, if the same force is applied, then the bigger mass, so you divide the force by the mass. So the bigger the mass is, means the acceleration will be smaller. And so therefore, B must be the correct answer. For question number 9, it said, what is the momentum of a 3,000 kg train moving at 2 meters per second? And so the formula for momentum is mass times velocity, right? And so therefore, to find here the momentum, simply what you're going to do is to multiply the 3,000 kg by 2 meters per second, and so get 6,000 kg meters per second. And so therefore, D is the correct answer for number 9. For number 10, it said the volume of a fixed mass of gas at constant pressure is graphed against absolute temperature. It said which choice best represents such graph? And so I put the law that is applied here, because once you say you have at constant pressure, you're talking about Charles' law. And Charles' law states that volume is directly proportional to absolute temperature for a fixed mass of gas. And so therefore, when we talk about directly proportional, then the graph that is applied to this is actually graph B. For graph A, it is proportional but not directly proportional. So let me explain the difference between graph A and graph B. For you to be directly proportional, you must go through the origin, which is where the x and y axis meet. So therefore, at the 0 point, the line must start through there. This is proportional because it did not start from or go through the origin. All right, so it's just a proportional graph. For the other options, these graphs are not applied in terms of proportionality. They're actually changing, so it's not proportional at all. All right, so you may have an increase, then it's stabilized. So it's not showing directly proportional at all. All right, so the answer there is B. For question number 11, it said, which of the following substances has the greatest density? And I work out each density here. And remember, density is equal to mass divided by volume. And so therefore, the highest density here will be A. All right, even though the mass is the smallest mass, but the volume is also the smallest as well. And so therefore, for option A, it is 20 compared to the rest. You can just pause and go through the calculations, and you'll see how I get the 20 kilograms per meters cube. For question number 12, it said which best describes the phenomenon shown in the diagram. And if you look at it, you have potassium permanganate in water, and eventually the potassium permanganate will spread throughout the water, which is a simple diffusion. All right, moving from a higher concentration to a lower concentration until evenly distributed. For question number 13, it said the diagrams, the arrows in the diagrams, the arrow heads show the direction of the force, while the arrow length show the magnitude of the force, which diagram could represent an object that is floating in water. And so I kind of put some notation right here to help us or to guide you in terms of understanding the concept. And so in option A, since the force that going down is greater, then that will generally will sink. And for option B, the two lines are relatively the same, and so here the weight that is going down is equal to the upthrust that is going up on it. So therefore, it will stay on top of the water. So it will be floating. So B is the correct answer. For option C is going towards the left because that's the only way the force is actually applied. And for D, this one will be floating in air or actually moving vertically through the air because the upward force is greater than the downward force. So this will continue to move upwards. So it's not floating on the water. It will move above the water. All right. And so question number 14 is which one of the diagrams shown in an example is an example of the first class lever. So looking for a first class lever right here. And I want to give a little thing to kind of remember to help you in terms of understanding types of levers or simple machines, right? And so I use FLE. And so FLE, whatever in the middle, it is that type of lever. And so if F, which is the fulcrum, if the fulcrum is in the middle, that's a first class. That's why I put F first. If the load is in the middle, then that is a second class. So it's in the second position, right? And E, which is the effort, if effort is in the middle, then that is a third class lever. And so if we look at the different options, we actually label them. So the wheelbarrow will be a second class because the load is in the middle. For option B, it is a first class because the fulcrum is in the middle. All right. And for option C is a third class because the effort is in the middle. And similarly to D, the effort is in the middle, which is the muscle. The muscle is the effort. So it's in the middle of the force and the load. So therefore, it's a third class. So the answer there is B. For question number 15, it said which row correctly shows the mechanical advantage of each type of pulley. The pulleys have negligible weight. So which means the weight is not necessarily considered in terms of measurement. It's too small to be measured, or just ignore it. So first to note here is that mechanical advantage is equal to load over effort. And you also need to know the velocity ratio, which is the input distance over the output distance, right? Just a point to note right here. It said by ignoring other factors, the mechanical advantage is approximately equals to the velocity ratio. And so this kind of give you an idea in terms of the mechanical advantage if you know the velocity ratio. And so just to make a note here on the first diagram, which is a single movable pulley, the output distance is reduced by about half. All right, because if you notice, by pulling this, the load will not move, or the effort, a matter of fact, will not move in terms of the full distance as the load. So it'll be half that amount. However, if you have a single fixed pulley, all right, what is needed to create this movement is that the effort must equal to the load, all right, and so also the load distance is equal to the effort distance as well, because they're moving in the same distance. While this is going up, the effort must move the same distance going down. And so it really is not a mechanical advantage. It really only allows work to be done easier. And so technically, if you think about it, for the single movable pulley, all right, you have a mechanical advantage of 2, so it's going to be twice easier. And for a single fixed pulley, it will be 1. And so the option there is actually C. All right, so let's jump into question number 16. It says, which of the following is not a scalar quantity? And again, I don't need to explain this. I mean, I've been through this many times. And so scalar quantity, they only have magnitude or size, all right, while vector quantities, they have both size, which is magnitude, and also a direction. And so the only one that has both, which is velocity, which is not a scalar. All right, so velocity has both magnitude and direction. For question number 17, it states that a 2,000 Newton net force is applied to accelerate a 50 kg block of cement across a rough surface. It said, what is the acceleration of the block? All right, here, in reality, because a rough surface, then of course it will be reduced in terms of the direct calculation, because of course friction will play a role, but they didn't give us any value for friction. So what we need to do here is just to work straight with the formula. Force is equal to mass times acceleration. And so therefore acceleration will be force divided by mass. So therefore the force is 2,000 newtons divided by 50 kg. Therefore the acceleration is going to be 40 meters per second squared. All right, and so therefore B is our correct answer. And again, you can always pause the video to look at the calculations to make sure you understand how we derive at each answer for various questions. All right, for question number 18, it said the table shows physical quantities and units commonly used in physics. It said which row of the table shows a physical quantity incorrectly matched with its unit. And so if you go through, again, I don't need to explain this, because once you know your basic and derived quantities, you should be fine. And so pressure is the incorrect one, because joules used to measure energy. All right. And so pressure could be force per meter square. All right. Because, well, I said newtons per meter square, because it's force over area. All right. So you can use that formula to define your units. All right. So let's jump into question number 19. It's a dog trainer uses a dog whistle to call a dog. The sound emitted by the whistle is heard by the dog, but not by the trainer. It's a what type of sound does the dog whistle emit, and why is this sound not heard by the dog trainer? And simple, in terms of sound that human ears cannot pick up, is really ultrasound. All right, and simply because it have high frequency. So this is a direct answer here. So option C is the correct answer. The ultrasound, and it's very high frequency above the human hearing. All right, so 20. It said, what is the symbol for a thermistor? And the thermistor symbol is D. The others are labeled variable resistor, heating element, fuse. And a thermistor can be used as a sensor or a switch based up on change in temperature. All right, and that's why thermo comes from heat. All right, and so 21 is a velocity time graph. So it's a use velocity time graph to determine the distance moved by the car. And so an easy way to calculate this is really to break up the graph into different shapes. And so we have two triangles and we have here a rectangle. And so how to find this part is half base times height. This is just base times height, and then we have half base times height right here. And so to calculate the total distance, you're going to say 5 times 20 because here is 10, so that's be 5 times 20. Here will be 30 times 20, and then here will be half of 10, which is 5 times 20. And so therefore the total distance there is 800 meters. Again, you can pause and look at the calculation to understand it properly. All right, so let's jump into question number 22. It said weight is an example of which quantity? And weight is a force. There's no going around it. So we don't need to even explain that because weight is equal to mass times gravity, right? And gravity is a form of acceleration. So weight is actually ma if you think about it, right? Which is weight is equal to mass times gravity. Gravity is an acceleration. So mass times acceleration is force. All right, and that is why weight is measured in newtons. Now, question number 23 is a radioactive iodine 131 has a half-life of 8 days. And just to point out something here that 131 is the mass, okay? All right, so it's if there are initially 4 grams of iodine 131 in a sample, how much would remain after 24 days? And so first step to do this is to work out how many half-lives you have. And so the number of half-lives, since a single half-life is 8 days, but the substance lasts for 24 days, so all you need to do is divide 24 by 8 to get the number of half-lives. And so we have 3 half-lives here. And so a half-life is the time taken for half of the nuclei or nucleus of a substance to break down. All right, or half of the sample. And you can say half of the mass as well. So, because remember, the nucleus determines the mass, right? So half of the mass, the time taken for half of the mass to break down, that's half-life. The time taken for half of the nucleus to break down, that's half-life. And so we have 3 half-lives here. And so since we're starting with 4 grams, then we must have 3 segments or 3 half-lives, or the breaking down of the mass by half 3 times, if we put it in that sense. And so 4, the half of 4 is 2. That's 1 half-life, right? The half of 2 is 1, which is another half-life, and the half of 1 is 0.5, which is another half-life. So since there are 3 half-lives, then the final mass after 24 days will have to be 0.5 grams. So therefore, B is the correct answer. Now for question number 24, it said, in science club, Mark wishes to demonstrate how a simple electromagnet could be made. And so you have a power supply right here, solenoid, and a iron core. He said, which row in the table correctly identifies the best setting of the power supply and the material to be used as a core for the solenoid? And so first to point out is that the power supply must be a DC. So therefore, A and C will be wrong, right? And then again, the core must be a soft iron core. So therefore, A and B will be wrong in this sense. So the correct option here is D. There must be a direct current, all right? And the core must be soft iron, all right? Because remember, only iron can be magnetized, all right? I think I jumped over the question too fast. All right, so question number 26. So we just passed halfway the paper. So it's a nuclide of uranium has a mass of 235 and an atomic number of 92. Is how many neutrons are present in the nucleus of this atom? And just to point out that 235 is the mass and 92 is the atomic number, also the proton. And so to find the number of neutrons, first to note is that mass equals to the proton plus neutron. So therefore, to find the neutron, it is the mass minus the atomic number or the proton. And so therefore, 235 minus 92 is 143. And so therefore, B is the correct answer. For question number 27, and this one reads that americium, which is 241, decays by emitting an alpha particle It said the mass number and proton number of this nuclide of americium are shown. All right, so here now we start with the americium, which is 241 and 95. And so it emits alpha particles. So this one, I didn't put the arrow in, put the arrow in. So this is going to give that, which is the product. So emit means give off, just to make a note of that. So that's the thing we need to know right there. It actually give off the alpha particle. All right, and so to run through this real quick now, what we're going to do here, since we get the alpha particle, and just remember that alpha particles are a mass of 4 and a proton number of 2. All right, and so just to determine the end product here, you minus 4 from 241 and 2 from 95. And so we end up here now, it is 237 and 93. And so if you add 4 to 237, you should get 241. If you add 2 to 93, you should get 95, right? And so that's how we know we get this mass and this proton number. And if you look at the periodic table, you notice that 93 element is neptunium. And so what you get here as the mass, I mean, this is not needed based on the question. However, just need to know, it said what is the proton number and mass number of the element formed as a result of the alpha decay of americium 241. And so here we have 93 and 237 as the correct answer. So option B is the correct answer there. Now for question number 28, they say which statement about evaporation is correct. And there's some notation on the side of each option just to kind of explain what is happening here. And so evaporation causes the temperature of the remaining liquid to decrease. Yes, that is true. And simply because when evaporation takes place, what is being evaporated actually carries heat with it. All right, just like when you sweat and the sweat is for cooling the body, it's the same concept that once you sweat, the sweat, once it evaporates, it takes heat away from the body. So what is moving away from the liquid when evaporation takes place carries heat. All right. And just for option B said evaporation does not occur in cold liquids near its freezing point, and that is not true because this can happen at any point above absolute zero. So evaporation can take place at any point above absolute zero. And so for option C said evaporation does not occur in very dense liquid. That's not true. All liquids, whether dense or not so dense, definitely evaporation can take place. The density does not affect evaporation of anything at all. And so it may affect how fast it evaporates. That's a different thing in terms of the movement of heat through the substance, but it doesn't prevent it from evaporating. The option D is evaporation takes place in all parts of a liquid is not true. It only takes place on the surface of the liquid. All right, that's where the gaseous substance will escape from the surface of the liquid. Question number 29. It said in a paper manufacturing plant, a radioactive source and a radioactive detector are positioned on opposite sides of the paper to control its thickness. And so if you notice here, you have a radioactive source on top and the radioactive detector at the bottom. And the radioactive detectors will detect the radioactive source and give a reading. And he said, what type of radiation is most suitable as a source, and what does an increase in reading on the radiation detector suggest? And so if you have an increased reading, it therefore means that the detector is picking up the source more powerful or easier. So therefore the thickness of a paper must be less. All right, so increased reading means thinner paper. All right, so let's talk about what source you're going to use right here. And so the best thing to use here is a beta. The reason why is a beta because beta is stopped by aluminum but not by paper. You can't use alpha because alpha will stop by a paper. So if you have a sheet of paper, you can't read it. All right, and so gamma is stopped by lead or concrete. So you could actually use gamma, but there's a difference now. Is that the amount of paper that you'll have, the reading will always be high if you just passing the detector through paper. The reading will always be high because it's stopped by lead or concrete. All right, so beta is best. And again, once you have an increase in reading, it therefore means the thickness of a paper is less. Increased thickness, the reading will become less because it's harder to pass through to detect the source. All right. So that's that for question number 29. For question number 30, say diagram shows two resistors connected in series with a 12-volt battery. All right, and it said what is the current in the circuit? And so to find the current, you have to find the total resistance. And so the total resistance in this circuit, it is 6 plus 12, which is equal to 18 ohms. Now, the formula, V is equal to IR, where V is the voltage, all right, or potential difference, EMF, and I is the current, and R is the resistance. So therefore, to find the current, which is I, is equal to V over R. And so therefore, V, which is 12 volts, divided by the resistance, which is 18, you get 0.67. And so therefore, the current in this is 0.67 amperes. Option A is the correct answer. For question number 31, it's a diagram shows a simple electronic circuit with two LED lamps connected in parallel across a power supply. All right, so an LED is light emitting diode, just to make a note there. And I also make some notation here that based on the diode, you need to know what side is positive, what side is negative in terms of anode and cathode. Anode is positive, cathode is negative. And so this side of the diode is a positive terminal, which is the anode. And this side where you see this cross line here, it is the cathode, which is the negative side. And so therefore, when you say cathode and anode, it means that that's the way you connect it. So you connect the anode to the positive side because that is the positive terminal. And the cathode is the negative side, so you connect to the negative terminal of the power supply. And so what they create there in this diode A is what they call a forward bias, and so you have glowing. For option B, it will not glow because it is a reverse bias, which means positive connect to negative and negative connect to positive. So the terminal or the electrode, they are actually wrong. And so which of them will illustrate correctly which LED lamps would be on when the switch is closed, and it's only lamp A, again, because of forward bias, and current will able to flow through it. All right, for B, current will not able to flow through it at all. All right, for question number 32, it said which energy resource is considered non-renewable? And off the bat right there, it is nuclear. All right, nuclear energy is not renewable, but geothermal, which is coming from the earth and is heat from the earth. And we have hydroelectric, which is using water to produce electricity, and solar, which is from the sun, which is always there, so it's renewable. All right, so nuclear energy is not renewable. All right, or otherwise called non-renewable. For 33, it's which energy transfer takes place when a matchstick burns. So if we burn a match stick, what is happening here? It turns from chemical energy into thermal energy, and also you get light as well. Light is not included, but this is the option anyhow. All right, because once the burning takes place, you get some form of light and heat. All right, so you move from chemical and chemical because of the match is a stick really, so it's a chemical compound. All right, and so once you burn that, you get your thermal and your light. For question number 34, it's a diagram shows a balanced uniform horizontal bar. All right, it's what is the mass of object M? And so to work this out, first understand the principle of moment, and which is state that the total anti-clockwise moment is equal to total clockwise moment. And so therefore 200 grams multiplied by 50 centimeter must equal to 20 multiplied by whatever the mass M is. And so therefore to find M is going to equal to 2000 times 50, which gives us 10,000 divided by 20, which gives us 500 grams. Again, you can pause to make sure you understand or at least know how to calculate this moment or to find unknown mass or unknown distance. Again, I have some videos on that. You can check them out as well. All right, for question number 35, It's a rod is made from 50% glass and 50% copper. It's a 4 pins A, B, C, and D are attached to the rod by wax. It said the rod is heated in the center shown. The pins will drop when the wax melts. Which pin will be the first to drop? And so heat will travel through the copper much faster than the glass because the glass is a poor conductor of heat. Copper is a better conductor of heat. So therefore, pin C will drop off first. And then I have pin D, and then pin B will be the third, and then pin A will be the fourth. But a point to note right here, though, right? We're going to consider that no heat was transferred through radiation towards the wax that holding on the pin, right? So technically, because the heat source is right here, B could fall off before actually D. But the way I put D to be the second one is we are considered heat is only transferred by conduction, right? So if heat is only transferred by conduction, D will fall before B. But in reality, because heat is around this area, and if this is held on by wax, then some heat will be transferred through radiation, and then B could fall off before D. All right, but if you're looking at conduction only, then the order that I have there, 1, 2, 3, 4, will be the correct order in terms of falling of the pins. All right, so question number 36. It said, there are 2 forms of heat transfer that required a medium for propagation. Identify the 2 forms. And so when I say a medium for propagation, which means heat must require a medium to pass through. All right. So for example, conduction is a passing through of substance like solid, for example, right? So conduction need a medium, solid objects, that is, and convection will need like fluid, liquids, and so on. All right. Radiation can pass through vacuum, really, so you don't really need a medium for that. All right, so therefore option B is the correct answer. Question number 37, and question number 37 read that heat energy is applied in a puddle of water causes evaporation. Which factor causes an increase in the rate of evaporation? And so option A is the correct answer to say that a breeze blowing across the surface of the puddle, and it increases evaporation simply because the wind will take away the evaporated liquid or the gaseous form of the liquid away from the surface much easier. It's just like you have you hang clothes on the line, for example, and if you have more wind, then the clothes will also dry faster because they take away the water or the evaporated water out of the clothes. A small surface area, which means the water will be in one clustered, which means it's going to be harder to evaporate. All right, if you spread it out, the water then evaporate much easier. So a thinner layer of water, in other words, will evaporate much faster than a compact or a greater depth of water. All right, of course, adding ice cube is going to make it cooler, so therefore it requires more heat to cause evaporation. High humidity, which means a lot of water already in the atmosphere, so it's going to be difficult to put more in the atmosphere by evaporation. All right, so question number 38. It said now, the diagram shows water waves passing through an opening in a barrier. It said what effect is shown in the diagram? And this again is a straightforward question because once water passes through any opening or slit or across an obstacle, then that is diffraction. And so A is the correct option there. For question number 39, it's the waves travel more quickly on the surface of the water when the water is deep. A stone is dropped at point X into a pool of varying depth. The diagram shows the first wave front on the surface of the pool, and then it said the region between X and which labeled point is likely to be the deepest. And so if this is a wavefront, I'm going to show you something with the diagram just to make a note right here. And there's something you need to know. In the diagram here, it said for the same frequency, and this is an additional note, for the same frequency, speed, right? Speed and wavelength, they are proportional. The speed and wavelength are proportional. Let me just make a correction right here. So this is supposed to be and wavelength, not and. All right, so speed on wavelength, they are proportional. So it simply means if you maintain the frequency and increase the speed, the wavelength is longer, because remember that speed is equal to frequency times wavelength, right? And so coming down from X, all right, for the same frequency, the wavelength going to get longer, so you have a more stretching effect on the wave front itself. And so therefore moving from X to C is getting deeper and deeper. All right. Question number 40. Is a parallel beam of light is incident on a plane mirror, which diagram shows how the beam is reflected on the mirror. And just to make a note right here to make a to clarify the diagrams really, is that when talk about reflection, you're talking about that the incident ray must equal to the reflected rays. All right, and so if you look at all the options, the only thing that look equal is B. So there, these you have the rays actually moving apart and so on. So those are kind of showing like refraction, which refraction do happen in mirrors. All right, you have reflection, and they must be equal. All right. So B is the best option right there based on what is happening here. This one you have converging and you have diverging of the rays. No, they don't. No, those are actually talking about refraction. All right, so 41, and we're almost there. It's a boy sees a fish in a lake. So which label path shows a light ray traveling from the fish to the boy's eye. And if you look at it carefully, the diagram carefully, to make sense of this, really, you're going to see that by understanding movement of rays, light rays, you realize that off the bat, A and B cannot be correct. Because if they go in a straight line, well, not A, because A actually going at an angle, then the refraction must go this way, must go towards the left, not towards the right, right? Based on how this is moving. And for B going in a straight line, so that should not have any refraction at all. It should continue straight up. All right, so C is the best option because it go at an angle, and based on the angle that is going, then it will refract towards the right. For D, if you're going this way, it will go more towards the right, which actually will not even go into the boy's eye. It maybe pass through where his hand is or something like that. So D is actually wrong because based on how it's refracting towards the left is not true. All right, so option C there is the correct pathway. For 42, it said the ray diagram for an optical device is shown below, which is a property of the image produced. And again, if you do not know about lens or understand lens, then I would urge you to quickly look at the number of videos that I produce in terms of how to draw ray diagrams for convex lens and also for concave lens. So you can check those out. I think I have quite a number of videos on that. I think at least 5 or 6 of them. All right, so you can just check them out to see how different images are formed based on position of objects. And so point to note here is that the image is on the same side as the object. So therefore, off the bat, it's a virtual image. Once on the same side, the image is virtual. All right, which means it's not real. Point to note again, the image is larger than the object, so it's not diminished. Diminished means getting smaller, so A couldn't be the answer. Laterally inverted only occur in mirrors, right? So when you look at a mirror, left is right, right is left. That's what it actually means. And it is not real, as I mentioned, because on the same side. If the image was on opposite side, then it says a real image, right? Again, check out those videos on lens, and you give a better understanding of how to form lens and so on. All right, for question number 43, it says which label distance is the focal length of the lens? And here, the focal length of a lens is really from the optical center of the lens to the point where the rays actually converge. And so B is the correct answer. I want to show you something with other diagrams though, why B is really correct. All right, so even though for option C, if you notice, is really from the optical center of the lens, right? To where the rays converge. But why is C incorrect? Because of that statement. The simple thing is that these rays, they're not parallel rays to the principal axis. So therefore, they will not converge like this at all. All right. And so just to make a note that only parallel rays refract. And so this diagram is totally incorrect. Rays will not refract like this, nor converge like this. So this is a totally incorrect diagram. For this one is a nice diagram. However, the focal length again must be from the optical center of the lens to where the rays converge. So this is way beyond that. So it's not the focal length at all. So that's why D is actually wrong, and B will be the correct answer. Again, you can look at those videos on lens, and you should be all right once you go through all of them. Question number 44 is which electromagnetic wave has the shortest wavelength? And so I give them in order from the longest to the shortest. And so you have radio wave, microwave, infrared, visible, light, ultraviolet, X-ray, and gamma. And so gamma is the shortest wavelength. Radio will be the longest one. All right, so you can just remember this. All right. Question number 45. And so we're going to have 5 questions to go. It said, what color does a red apple appear when placed in green light? So if you have green light only, what you need to remember, for you to see something, it must reflect the same light. And so if the apple is red and you place it in green light, it will absorb that green light, and so therefore no light will be reflected. All right, and so therefore the apple will appear dark or black, because red is not present to be reflected from that apple. So remember, whatever you're seeing is the color of light that is being reflected. The other colors will be absorbed. Again, you only use green light, so therefore no light can be reflected at all. And so therefore all the light is being absorbed, and if there's no reflection of light, it becomes dark. In other words, you cannot see the object. All right, technically you're not seeing the object, so it appears as darkness. Darkness is absent of light. 46. It said during a musical rehearsal, a violinist only tightens the string of the violin. All right, and so what difference will the change make to the sound produced? And so if only the string of the violin is tightened, then what's going to happen here, you're going to have a higher pitch. All right, so therefore means you have an increase in frequency. All right, increase in frequency. So A is the option. 47, it said 2 uncharged balloons are suspended by thread a short distance apart. After each balloon is rubbed with a soft cloth, they repel each other as shown in the diagram. And so if you notice here, we have X and Y. These are the uncharged ones. They're really close to each other, but as soon as you rub them, they start to repel. And so just to make a note right here, so which statement is true about the changes of the balloons after being rubbed? And so for them to repel, just to make a note here that like charges repel, so they must be the same charge, and unlike charges will attract. And so therefore, A is correct because both of them will be negative, all right? The others, if we go through them, they realize that they are different charges, all right? And so they must be the same. They must be same charges for them to repel. 48. It said 4 current volt graphs A, B, C, and D are shown. So it said which graph represents a component that obeys Ohm's law. And for you to understand this, I must go through Ohm's law real quick here. Ohm's law is at a constant temperature, the electrical current flowing through a conductor of a fixed resistance is directly proportional to voltage across it. And so, point to note, if it's directly proportional, so the key word here is directly proportional. All right, so if current and voltage are directly proportional, the only graph that shows direct proportional is graph B. Again, direct means it must pass through the origin, all right, and must contain a straight line like that, which means as one increases, the other one will also increase. All right, so option B is the correct answer there. For question number 49, it's an electrical iron used as a power rating of 1.5 kilowatt. How much energy in joules and kilowatt hour does the iron use in 10 minutes? And so I can break this on into 2 parts of calculation just to show you this workout. I did actually the kilowatt hour part first. And so point to note here, if it is 10 minutes, change the 10 minutes into hours by dividing by 60, which you get 0.17 hours. And so to find a kilowatt hour, which is easier, you have a kilowatt, which is 1.5, and you have the hour right here, 0.17. Multiply those two numbers, you get 0.255 kilowatt hours. So we know the answer must be 0.25. All right. So again, right off the bat, you'll know that D is the answer. But let's prove if the 900,000 is actually correct. All right. And so to find energy in joules, it is power times time. All right. And time must be in second and power must be in watt for you to get it in joules, not kilowatt, but in watt. And so in seconds, 10 minutes in seconds will be 600 seconds, right? So 10 minutes in seconds is 600 seconds. Just multiply it by 60. All right. And the watt, we need to convert now the power in watt. And so we have kilowatt, which is here 1.5 kilowatt. And so if we multiply this by 1,000, get 1,500 watt. And so since you have the watt in the power in watt and the time in second, all you need to do is to multiply them as power times time and you get 900,000 joules. All right. And so we know that D is the correct answer. Again, you can pause this and go through the calculation over and over to ensure that you understand it. Now for question number 50, which is the final question, it's a washing machine contains a 13 amp fuse. It's a which response correctly shows where it should be positioned in a household circuit and the function of the fuse. So right off the bat, a fuse must be placed in the live wire because the live wire is where you have your voltage or current flowing. And so remember now, since the ampere will break the circuit to prevent excess flow of current to create damage to the appliance, then it must place on the live wire. So we know that C and D will be out of the picture already, right? And so the purpose for the fuse is to break the circuit when the current exceeds 13 amperes. So anything above that fuse rating will cause the fuse to break and current will stop flowing. And a matter of fact, the purpose for this is a protective reason to protect the devices, to prevent electrical shocks, to prevent fire and all those type of stuff. All right, so that's it. That's the final question. So we finished. All right. So anyway, thank you for watching, and I hope you do well on the examination. And I will definitely talk to you soon. Be blessed and take care.